Excellent. All right, guys, we're back. And I was so inspired by Empty Code and him sharing about Jonathan Blow that I watched a little bit of this. And to be honest, again, I'm not the knower of all things. I didn't know who Jonathan Blow was. I just started watching this video, and to begin, I want to say that the things that he was saying in this really resonated with me. And that's before knowing anything about him. I truthfully did not know who he was. I know now. But just a couple hours ago, I didn't. And the reason why I'm sharing this is in the VOD where we were talking about him very briefly, or the stream where MG and I were just talking about him, I was mentioning how the things he was saying were really resonating with me. And I could tell just from him talking is that this is somebody that has done stuff. This is the vibe that I got, is that this is a man who has accomplished things, because the way he was presenting this, and I want to quickly watch a little bit about this oh no, it might have gone off the thing. We'll find it. But it's basically this episode on like work-life balance. Needless to say, ever since discovering Jonathan and listening to some of the things he has to say, and now understanding what he's done, I'm a huge fan. Huge fan. Almost instantaneous fan. This guy, I think, is speaking the truth. I think that he's trying to help people, and I think he's nailing it. So I'm going to have us watch this, and I'll give feedback throughout. And then if we have time, we'll find the second one where he's talking about like work-life balance. Woo-wee! That is just like music to my ears. And by the way, I want to be clear. This is not for everybody. Like if you don't want to be, in Jonathan's words, an Olympian, or in my words, world class, this is probably going to seem pretty extreme. But I think that this is what Jonathan and I are getting at, is we're trying to explain for people that really do want to achieve incredible things, views that we have on how we've been able to do the various things that we have. Whether people consider them incredible or not is up to them. I suspect probably just like Jonathan, I'm not like proud of my successes. I don't really use this word. I'm pleased. I'm happy that I accomplished these things, but it's not something that is an excuse to rest. All those things that I've done in my life, I kind of see it as those are building blocks and stepping stones to get to where I'm really headed. And right now, where I'm really headed has a lot to do with Merle and machine programming. But in 10 years from now, it might be something else. I don't know. But I can tell you almost definitively the things that I'm doing at Merle and at the uni right now, as well as GTT, are also going to be stepping stones to that next thing. And I think when you start to look at it like this, it's no longer bragging about what you've done. It's recognizing that you've achieved things that some people might think are magnificent, but you achieve them not so you can be magnificent or amazing or whatever. It's so you can go on to do harder things. But those other things had to be done first, right? Like you can't just start building the top of the pyramid. You have to start at the base and then build another level and another level. And so I get the feeling that this is what Jonathan is doing, and it's very similar to what I'm doing. Before I play the video, I want to mention one other minor detail that I just noticed, which really kind of warmed my heart. For those of you who've been following GTT long enough, know that when I first started this, I had my task bar at the bottom here. And I did that because I was basically handicapped by Windows 11, and it was really annoying me. And then because I actually said something on a stream or on a VOD about it, I realized, gee, Goju, you should like eat your own dog food and spend some time trying to figure this out rather than just complaining about it. So I spent some time, and truthfully, I did look at it before, but there was no solution. But I hadn't done that in like 6 months. So I didn't immediately just start complaining. Just to be clear, I did complain, but at the time I didn't see a solution. Now, when I looked again, there was a solution. So you can see I have this guy over here, and I think many of you know the story of why I did this. It's mostly for eliding away the limited vertical space that we have, especially when we look at code or other things, and that we generally don't need the whole widescreen field of view because people can't read very well really long things. And you can even look at this comment here. This is a long comment where this stuff is much easier to digest. This is where we have the 80 column rule. It's not because we can't, I mean, we're not limited by terminals anymore. This can be actually a really good thing. And again, don't take my word for it. Go ahead and read the intrawebs, and you can find all about this and the psychology behind it. You know, it's one of the key hacks in life to very simple thing. Just narrow the column of view for what you're reading, and you will read faster because your eyes go up and down very easily. Whereas this, we already have that space, right? But you can only focus on this. So, uh, so that's the first thing I noticed is, gee, it seems like me and John both have the same idea. And that's awesome. And I think that he might be using Windows 10. And Windows 10, this was not a problem. Windows 11, it was, but it's fixed now. Or at least I have the fix through Stardock. So, Jonathan, if you're out there watching this and you're running into the problem, I think that you're a kindred spirit wanting this. And believe me, brother, I know exactly why. If you get Stardock, you can change it and put it off to the side back to where you have it. Okay. The next thing I want to do, because I think all's fair in love and war, is and mostly I want to do this to just give demonstration of objectivity. That you can absolutely think that someone is great and think that they've done amazing things and still be critical of them. And so I'm going to do that here. Now, this code that he's showing, I don't know who wrote this code. So it could be Jonathan's, it could be somebody else's. But since we have code, and this looks like this is in C, I want to just poke at it a little bit to try to assess stuff. So the first thing that I would say is this looks very heavy, never breaking, never nesting. Whenever I see a lot of else's, I immediately think people are not fully understanding how to escape out of functions to do the right thing. Now, given that this is C code, it looks like it's C code when I see things like mprintf rather than C out and out and just OS, sorry, output streams and input streams. So O streams and I streams. When I don't see those, I think more C. And when I see strings that have embedded percentage signs, I think more C. So in all fairness, I want to say that this code is probably written in C, and therefore C doesn't have the same type of object destruction capabilities when you go out of scope. So the hack for that is usually go-tos. And it could very well be that Jonathan is like, I'm not doing go-tos because that's worse. Like, I get it. This is why you just level yourself up and you write C++. No disrespect to the C people. We love you. Many of us started there. I did. And it's super powerful, but like deterministic object destruction it's a superpower. Scoped objects that deterministically deconstruct. Yeah, as my kindred spirit of untranslatable metaphor is saying in my ear right now, RAII. Let's actually just bring this up real quick. How do I do? I think I do this. There we go. RAII. Resource acquisition is initialization. And untranslatable metaphor is absolutely on the money. This is a super powerful thing. Basically, uh, the way it kind of works in theory is, let's just say that you have this object O, and then it equals something, and dot 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 dot, and then you have these like scopes, and then this O is going to get destroyed here. Okay, so this is sort of RAI in a nutshell. The idea is that the initialization is the point where you do resource acquisition. I still think you can do resource acquisition elsewhere. Like you saw it in one of the cases where we were writing code and I allowed something to be acquired in the initialization of the constructor, but I also allowed you to set it later. But what is generally the flip side of RAII is this deterministic destruction. And this is a thing of beauty because this guarantees that essentially any path of execution in this function, no matter where it exits here, exits here, exits here, it's going to invoke that destructor, which means that you can guarantee that these resources or these things that are being acquired at initialization or construction can be released if you want them to be at destruction. Why is this relevant to this discussion? Well, when you don't have this behavior because you don't have objects in C, you generally have to have a space where you can do this release thing. And generally speaking, where people have done it historically is like in these cleanup sections for go-tos. Otherwise, it's very hard. Or you have a cleanup function, but then again, it's still, how do you ensure all paths go to this? So one way that you handle this in languages that are not object oriented is you end up having to write more if and else's, unfortunately. So again, I want to be clear that if this is Jonathan's code, I'm not picking on him per se. He could be limited by the language, but at the same time, then I would just say, let's just level up to a language that has objects that have RAII and can get us fun stuff. Okay, and it looks like Empty just hopped on the chat. Let's see what he's got to say. Jonathan's very practical. He is pretty much anti-design pattern and the average coding style. The current game he's writing is written in his own programming language called Jai. Or J. It looks like JAI. That's awesome. I love it. And truthfully, most of the superhero coders that I know, they've all created their own programming languages. So I've created a few. My chief engineer and chief architect at Merle, Urs, who's written millions of lines of code. Urs has actually probably written more code than I have, even if my code's like a little bit better than his. He writes more code though. He's faster, definitively. Like, I want to just be clear, and I'm only poking fun. Urs writes amazingly robust code, but Urs has also invented numerous programming languages, and one of them, I think, got licensed from Microsoft Research or something. But anyway, so I love that he's writing the game in his own language. In fact, in Nautica, this was one of the things that I did is I realized I wanted really advanced mobs that their behavior couldn't be programmed through like simple enumerations or something. Like I wanted really complex, powerful logic because I wanted them to do stuff. I wanted them to be able to like create teams, or I wanted them to target specific people, like take the clerics out first, right? Or like if you're in an unbalanced fight, run away, get reinforcements and come back. Like I wanted it to feel like these dudes are going to outsmart you if you give them the chance. So you better like come with your A game. Anyway, that language, that programming language, what's called the Nautica AI programming language, that language has more code written in it than the actual core source code for Nautica in C++. That's right. I mean, we're talking on the order of tens of millions of lines of code. There's one mob, I think, in Nautica, one mob that its AI system is probably, it's got to be like at least 50,000, maybe 100,000 lines of code. I mean, it's, and part of that, to be totally clear, like just so this doesn't go off the rails and we just start inflating all these numbers. Part of the reason why there's so many lines of code in the Nautica AI system is I designed it the wrong way. I made a massive mistake in the way that I designed it, which didn't directly allow for standalone functions that could be called into. Instead, I made it basically a fully embedded tree because I thought that's all we would need, and I was wrong. And so, unfortunately, part of the the reason why the size is so big is you have to replicate certain blocks because I'm dumb, or I was dumb when I was creating that than I am now. If I wrote it again today, I would solve that problem. And then, of course, there'd probably be new problems that I'd need to solve. But anyway, I think you get the point. So I love that he's creating his own programming languages. I think I heard something on that. This guy just screams baller to me, like, just right away. So as Empty Code is saying, one of the things that Jonathan has done is he created the game called Braid. Now, what's interesting is while I hadn't heard about Jonathan before, I had heard of Braid. And I had heard that Braid was this game created by this indie developer and people were super impressed. I played Braid and I loved Braid. I thought the game was brilliant. That the game design itself is it's just like masterclass. I don't remember all the details, but it has something to do with time, where it's like you could move forward and then you kind of realize you're making a mistake. You kind of like move time backwards. But it was more sophisticated than just this, is that you could do a bunch of things. I may bring it back up. Okay, I don't see it in here, but yeah, trust me, I played this game. It's spelled BRAID. Maybe I got it on Good Old Games. I don't know, but I recall being like quite impressed. And it has this really cool artsy feel to it too. It's like I just remember these clocks and stuff, and it kind of felt, it just has a certain sort of nowhere feel to it, where it's not trying to be. It's like steampunk. It kind of feels a little bit like a steampunkish kind of game. Anyway, so now let's quickly look at Jonathan's code. Oh wait, one more comment. Also, the game has an engine which also written his own language, so he's working on the. Yeah, this guy sounds incredible. I mean, I'm yeah, I am a huge fan. In fact, Empty, just so you know, I found his channel and I'm already subbed to it. So I plan to watch him more, and I plan to actually do a lot more React videos to him because I get a sneaking suspicion he and I are cut from a very similar cloth. Anyway, so now just to show you that, like, it's important that even for people you're big fans of, you can still be critical of them because it can help you grow, or help them grow. And just because you're critical of someone doesn't mean that you aren't totally in their corner. Because as we've discussed many times, at least my view is that none of us are perfect. None of us are done. We're all a work in progress. At least that's my view. And if, I've mentioned this many times, but if you join Merly, if you want a job at Merly and I ask you, like, what are the areas that you need to grow in the most? And you're like, no, I'm a baller. I don't really need to grow. I'm good, actually. I'm pretty sophisticated, and I've learned stuff. I'm just being me. I should be accepted just for me. I absolutely would never hire this person. Nope, not in a million years. If anyone wants to join Merly or do research with me or any of these things, and they tell me I don't need to grow, I'm uninterested, because I think that is one of the most important things to life. And anyone that thinks they're finished or they're just like done they probably are done. Like, as in, they're probably not going to be contributing much. And so I love that he's got this growth mindset of constantly pushing things. I think that it's going to get real wacky watching some stuff, because I tend to be not super fiery on GTT, mostly because I don't want to, like, I know that I'm a bit in La La Land here and I'm a bit crazy. And truthfully, and this is probably the part that's even more different. I think Asmongold talks about how in real life, he's like quieter and he's more to himself. I'm the opposite. In real life, I'm like full blown lunatic. Like you guys get the kind of chill GTT, the chill Goju, who's like, hey, it's all good. We can all like work together and stuff. But in real life, oh yeah, I mean, if you don't believe me, just ask Taylor sometime. He'll give you the lowdown. And anyway, I mentioned this because what happens is the more I'm around fiery people that have similar ideological views that I have, the fierier I get. So I have a sneaking suspicion that if we start watching John's videos and I'm doing reactions, I'm gonna start leveling up, and it's gonna get a little wacky in here. So anyway, okay, about his code. So um, I noticed a couple things. Um, there's one I wanted to jump to right here. This one jumps out to me immediately as it's just lazy. Here's what you do. I mean, the fix to this is super simple. You assign, um, and maybe this is a broken case. Maybe there's a reason why you can't do this, but this is just my knee-jerk reaction. Is you construct this uint64 high val, you immediately assign it to this. You assign it to this. Then, if bits is equal to 64, and you invert this, by the way, 64 is equal to bits, just save yourself the trouble of the accidental single assignment, then you set high val to this. Why do you do it this way? You do it this way because then you get rid of the else, and you reduce the nesting. Okay, now, there is an argument on why you should do it the way that he has it, which is if you do it this way, then you're only doing like a single assignment and you don't do this bit shifting operation unless it's necessary. And so what it kind of feels like, yeah, maybe you could invert it. So let's rehash this because this is an if else. And this is just my quick knee-jerk analysis of the code. I could be wrong. I don't know all the context of this, but one potential path is you set high val equal to this very large -1 number, 64-bit -1 number, and then you say if bits is not equal to 64, then you do this. Either way, I prefer because I don't like the unnecessary branching. And both of those paths will essentially get rid of this else. And I think this code needs reduction of else's. Right? I haven't looked at it enough to figure out if you get rid of this else here. I bet maybe you could. Down here, I'm sure if we massage this, we could start to figure stuff out. Like, for example, if I were to look at this, yeah. So the one thing that I'm not a super fan of is I don't like the level of nesting. I think that you could improve the readability of this code quite a bit if you went through and you hacked on some of these things to do things like RAII or just do the initialization and then cut out some of these. And by the way, like this is not a knock on Jonathan or anyone. We can all grow, right? And so maybe I'm more comfortable in C, C++. And so please don't take this as like I'm coming down on him. It's more just like we're just being objective code analyzers. It's sort of like what untranslatable code does with my code all the time. He's like, oh, well, this is wrong, this is wrong. And like, I know that he's like a huge fan. The next thing I want to say that I absolutely love, while I don't love this condition, I don't love this condition just because whenever you combine bitwise operators with logical operators, I think it creates unnecessary confusion. But that aside, one thing I absolutely love is this. I love that they have created a name for this literal. This is basically, it's saying literal numeric negative integer. And what he's doing here is, I suspect this is behind a pound define, and he's not plugging in the value directly on purpose, because he knows that you shouldn't see that. You should see what this means. And when you understand the meaning of this, that's all you need to know. You don't need to know the value. Like this. Could very well be that this is this. And this should also say this. That's my guess. But somebody didn't update this. And then maybe Jonathan came in and was like, we shouldn't embed all these literals. They should be called, you want to embed a literal, just have it be called literal numeric negative integer. And then you've got it. So I absolutely love this. And this goes back to what I was saying before about how try to avoid embedding literals into your code. So to go again, this is, I said there's basically 3 cases where I see embedding literals is not super bad. I still don't love it, but whatever. Those cases are 1, 0, and -1. If it has any of those 3 values, it kind of is like, well, okay, because this is like, for example, this -1, I get it. This 0, I get it, right? Sure. And so this -1, right? I get it. That being said, I think that this is better. And then as we go further, I don't totally love these leading underscores just for conflicts with standard libraries and things. But again, they might just not know. And yeah, aside from that, I think that I don't have too much else to say. I guess I do love that they use size types. This gives me an indication that this is probably production quality code. They want to know for sure that they're actually dealing with 64-bit integers. Great. It's amusing to me that they dropped the I. I'm not sure what I think about that. I'm assuming this is an int 64 that's unsigned. Maybe what they have is an I64, and then they created a U64. So they're like sort of symmetric in size. And so the signed one just is called I64, and then the unsigned is just U64. I usually see these things as like UI something, but that being said, the takeaway is using size types is generally a very good thing, especially if you're trying to build world-class code that is highly performant, but it's also highly portable. You can build really fast code that doesn't use size types, and then you lose the portability. Or you could build code that is highly portable, that just kind of abstracts away certain type information, but it's not likely to be as efficient as it needs to be for reasons that are probably outside of the scope of this discussion. But this is also a really good sign. I like too that they've got comments in places, and it seems like this one I quite like, even though it's a bit long. How they say, we know that high value is not negative, so we cast to U64 here. It's this part. Let's do it explicitly for clarity. That part is key. Is what this is cluing into the reader, at least for me, is it's saying, listen, I know that you think we don't need this little cast thing. You're probably right. Don't remove it though, because I want people to know that this is being cast to this, even though we know high value is not necessarily U64, and I don't want to have like the wrong implicit converter to kick in. I like that. Then what I also like is that he says, let's do it explicitly for clarity. It also protects the comment. So then some junior programmer is coming in and it's like, well, it's so obvious. Let's just delete this. Well, the comment is there to say this, and it's to say doing it explicitly. So don't delete this. And don't delete this comment. I mean, that's a good comment in my mind.